I always like talking about the potential for life in space. And as we develop more sophisticated telescopes and data processing systems, we've vastly increased our ability to learn more about the cosmos, and to see where and in what conditions some other kind of life, alien life, could reside. Our biggest intuition in this search is that life will be like us, carbon-based, water-dependent, and comfortable in the same general temperature range as us, that can still sustain liquid water. This is a good starting point, because we know this kind of life can exist. We are that kind of life, it's us, but there could be other kinds of life, with different biochemistries and different environmental comfort zones. Theoretical biochemistries explore ideas like methane as a solvent instead of water, or silicon as a full or partial alternative to carbon, and so on. The alien life might not even have cells as we understand them. What could be fatal to us could be comfortable to them, or something they eat on a regular basis, and vice versa. They could live in ice-encrusted oceans on moons orbiting a gas giant, which is a planetary environment that's vastly different than our own. The problem here is that these kinds of alien life in these kinds of habitats, at this point, it's still pure speculation. Until we send a probe to Europa and it's able to drill through the ice and send a little submersible down, and it sees alien fish swimming around, and we know for sure that this is possible, until then this is all just speculation. Until we get hard data, or rather squirming, gooey biological data, we can't know for sure if this is probable, or plausible, or even possible. The thing that you should remember here is that the possibility for alternative life is there, it exists. There is a chance that life could exist in other forms, on other types of planets. So the news that I want to bring you today is about a study from Penn State University, which analyzed data from NASA's Kepler telescope. They analyzed more than 530,000 stars, looking for dips in their brightness that might suggest an orbiting planet. This technique identified more than 2,600 exoplanets. The study included a mass analysis of these planets to make a data-based estimate of how many are Earth-like and how many there are in the galaxy. By Earth-like planets, they mean something rather specific. Rocky planets between 0.75 and 1.5 Earth masses with an atmosphere, a temperate climate, liquid water on the surface, and orbiting in the habitable zone of a Sun-like star, which in our case is a mid-sized G-type star. They're using this very specific standard because it's our standard. It's the Earth and all the life on it. It's the one hard data point that we have where we know for sure that life can and does exist, in this particular waterlogged carbon-based form. If you're familiar with the Drake equation, then you know that the numbers involved in this kind of thing are huge, and because of that, the probabilities for life are usually pretty high. So this is what the researchers found. The broadest estimates suggest anywhere from 20% to 50% of these Sun-like stars have Earth-like planets around them. Although, being more precise with our limits for defining a Sun-like star and an Earth-like planet, they would settle on a rate of about 1 in 4. 1 in 4 Sun-like stars in our galaxy is host to an orbiting Earth-like planet, potentially replete with a diversity of life and a global ecology as rich and complex as our own. Eric Ford is a professor of astrophysics at Penn State and a co-author of the study. He said, quote, "There are significant uncertainties in what range of stars you label Sun-like, what range of orbital distances you consider to be in the habitable zone, what range of planet sizes you consider to be Earth-like. Given those uncertainties, both 5 and 10 billion are reasonable estimates." Unquote. So that's pretty incredible. In our galaxy alone, there could be as many as 5 billion planets, very similar to the Earth, with liquid water and a comfortable climate, or even up to as many as 10 billion of those Earth-like worlds. The potential there for alien life to exist, or for some kind of multi-planetary interstellar civilization, the potential for that exists, and that's pretty incredible. Now consider that this conclusion was generated with a sharpened definition of an Earth-like planet. If you consider less Earth-like worlds that still might be able to host some kind of extreme evolution of life, or if you consider stars that aren't quite like our sun but still have Earth-like worlds around them, the number of worlds capable of bearing life is much larger. And if you consider the really exotic worlds, like life in an ice-encrusted ocean in a moon orbiting a gas giant, just like Europa and Enceladus and Titan in our own solar system, well, the number of potentially life-bearing worlds increases even more. It's really exciting to know that the more data we get, the more we learn and understand about the cosmos and about stuff like the deep biome, the more likely it seems that the galaxy is filled with life.